Good afternoon. Good afternoon. Thanks for being here. I will talk about a new species for aquaculture in South America. It's the black drum, southern black drum, Pogonias corvina. It's going to be a description of what we achieved in our first year with reproduction and larviculture, and a few notes on grow out. So I came all the way from southern Brazil to Madeira. It's a long flight, and here is located our campus in the Federal University of Rio Grande, very south of Brazil. An aerial view, we are right in front the beach. This is our hatchery. We have a graduate program in aquaculture. It's a master's and a PhD program at the Oceanography Institute at FURG. Another view of our lined ponds. And here is the new famous black drum. This is actually a species that was called Pogonias chromis, which is the same in the Gulf of Mexico. And a few years ago it was split into two species, and the one in the south is now called Pogonias corvina. This is one of our broodstock. They can live up to 55 years, can weigh more than 100 kilos. Very interesting species for fisheries. And in the 70s, 80s of last century, it was an important fishery in Brazil. Landings were around 2,000 tons per year. And by the 90s and during this century, it collapsed totally. No more landings, only sports fishing that you can catch one of those. This huge one you don't see anymore, but it's becoming a little bit more popular with sports fish. Well, this is the day we stocked our broodstock. We collected by hook and line, and we had fish as small as 100 grams. Here you can see the initial weight of the fish. The largest one weighed 3 kilos, and after this was in July and December of the same year, they had grown quite a while. And this February, the largest broodstock was weighing 8 kilos. So they were pitch tagged, and we've been following them for 20 months. Now 4 months, 2 years almost. This is the gonadosomatic index in the wild. November, December in Brazil, it is spring, summer. So this is the peak spawning for the black drum. And what we observed in captivity was spawning in November, December, so following the natural spawning period in the wild. So we kept it rising temperature and light period, simulating summer and winter. And they spawned again this year, started in November, and we had spawns up to January and February. Fertilized eggs are similar to most of marine pelagic eggs, but I'm not sure if it's a problem with the eggs or this species is a little bit different, that it won't float all to the surface. They get spread in the column, so it's difficult to we cannot collect all the eggs, so we're not sure how many eggs we are producing, because they remain in the water column, not actually at the surface. And we are near a large estuary, and so our salinity is 30, 32. We increased the salinity to 35, 36, so we would have a better floating situation, but still we don't get them all in the surface. Could be some problem with egg quality or some peculiarity for this species. So for the larviculture, we had a few days with Nanochloropsis oceanica, a species that is common in our hatchery, along with Brachionus, followed by Artemia naupli. So as early as 6-7 days after hatching, we can already start with Artemia naupli. And enriched Artemia, we will start 10 to 12 days after hatching. Co-feeding started at 14 days, and by the 21st, 22nd day, they were fully weaned. It was a good surprise for me. I was used to work with flounder, and it took more than 2 months to get them fully weaned. So 22 days was actually a good surprise. And then they go on dry diets without problems. And the Artemia, we can introduce it a little bit earlier, I suppose, because in one of the larviculture runs, we did not have rotifers one day. Something happened, and so let's give them some Artemia, and they were happy with it. So we are trying now to improve this weaning process. Perhaps we start with co-feeding along with rotifers and see if we can spare some Artemia. This is our experimental hatchery. We have a few systems in recirculating, and this is where we run the larvicultures. So it's a light green water. We don't put that much algae, and we seize it when we quit the rotifers. All live food is given by hand. And here we have larval growth and weight. So they reach 300 to 400 milligrams in 1 month. In one particular larviculture, they were as large as 700. So I think we are getting better along with them, and we can improve these growth rates. And here, regarding length, they reach 3 to 4 centimeters in 1 month. We recently worked with the histology, so we have the newly hatched 2 days after hatching larvae, typical larvae with a large yolk sac, and the digestive tract is still undifferentiated. And 2 weeks after hatching, they already have a well-developed digestive system. You can see the intestine, the swim bladder inflated. They don't have a problem inflating the swim bladder, and liver, stomach full of food. So we were very happy with the larviculture that we run here a closer look at a 20 days old larvae, full with microdriads. So this is a view of the fingerling when they were about to finish the 30 days after hatching. How's the time? And so our fingerling production in the first year, we produced around 50,000 fish, and all of a sudden we had too many fish in the hatchery. We could not handle all that fish, and so we started an idea of stock enhancement for these species, but I'll show you that later. Regarding the reproduction in larviculture, what I have as a conclusion is this species will spawn naturally in hatchery, and we caught them in July, and they started to spawn in December, January. So they were really, and they grew very well during this one semester in the lab. So I could say it's a very easy going fish for aquaculture. They can be fed on the typical larviculture protocol, rochefort and artemia. We can wean them as early as 21 days after hatching. We did a preliminary weaning, earlier weaning, and we finished it by 17 days after hatching. They were fully weaned. So with all these results, what I can say is that this is a species with a good potential for aquaculture in South America. Marine fish farming is not really a reality in Brazil. We have a couple of small-scale cobia farms. Now there is also a couple of companies working with grouper, but it's all very, very small scale. So Brazil is always mentioned as a very big potential for marine fish farming due to our 8,000 kilometers coast, but we are still on the way to find our best species. And it's not a lack of technology to produce the fish. It's a matter of getting a company to produce the diets, and but they will produce the diets only if you have big production. So we have to see who's gonna give it first. Well, we cannot grow fish without diets, and they don't sell diets if you don't have fish. But then we kept these fish. Some of them we kept in the ponds that I showed you before, and others were in 15-ton recirculating system. Didn't mention survival. It's amazing. It's 100% survival. You get 2,000 larvae in a tank, and after 30 days, you count them. You have 2,002 plus 2 minus 2. It's I've never seen nothing like that. So we get after 15 months of age, 12 months of grow out, we got fish with average 500, 600 grams. That's very, very nice. Our flounder would not get close to it. And if we look at the brood stock, when they weighed around 500 grams, 600 grams, in 6 months they went up to a kilo 300 grams, 200 grams. So we had 12 months of grow out, getting to 500, 600 grams, and projecting a growth for another 6 months. We would reach reaching fish of a kilo and a half in 1 year of production. And so we are looking for this stock enhancement program. So as this fishery was completely knocked out in the end of the last century, we tried several methods, from releasing fish from the ship on the shore, and we could manage them quite well, transporting them on board and to the beach. So they really could be part of a stock enhancement program. And again, at the University of Rio Grande, I would like to mention our graduate program in aquaculture. We do offer some grants. We have a possibility even for foreigners to get a grant to study in Brazil. And you can look at aquacultura.furg.br if there's someone interested in studying in Brazil. I would like to acknowledge our main sponsors, Brazilian CNPq, National Research Council, the project AquaVitae of the European Union, a local funding agency, FURG. Thanks to AquaVitae for covering the costs of my trip over to Madeira. And I thank my students who do the hard work while I get to travel. Thank you.